挑战相关的难度。
腿甩，请启车盖头。
Okay. So good afternoon to everyone. Yesterday we were a bit slower, so maybe today we'll go slightly faster. So we want to cover stuff in the midterm. So I always believe that the learning curve is not linear. It's not linear. You know what I mean? You know what I mean? Learning curve is not linear. You know what is linear? Linear graph, you know, right? Well, I think that's not linear. So what should it be? What do you think? Exponential. Sort of, I think. Sort of. Huh? Logarithmic or that one is a die. Yeah. Genius. Huh? So maybe exponential like that. Right. What else? Logarithmic. Logarithmic. Yeah, like going to a plateau. Stop already. Sine functions. Wow, that one too dramatic already. Very dramatic. Maybe you can put in a reciprocal. We can discuss about it. What do you mean by tangent? How is it tangent curve? What's tangent curve? Oh, tangent. So like exponential, kind of faster, maybe faster. Being faster. Yeah, cool. Okay. Good. So I'll think about this exponential. Okay. Or maybe sometimes is this continuous, you know? Sometimes it jump. And suddenly, so here is sometimes maybe we call a Eureka moment. 有听过吗 ？Eureka moment 啊，Eureka moment 知道是什么吗？你们有没有这个 Eureka moment 过？啊，我终于知道了。哦，原来是这样。不是马后炮，不是马后炮的意思就是你知道了嘛，但你后来你才讲，这个是你一开始不知道，一开始你不知道，但突然间你知道了。哦，叮，有一个灯泡跑出来。马后炮是你懂了，你已经懂了，但是你不要讲，后面才讲，这是马后炮，懂了。反正别人就是来 Eureka moment，突然间发现啊，而 this one 呢，maybe 老人家会讲嘛，哎呦老了啊，学不了这样多东西了，可以怎样更学？这个呢，啊，先讲忘记了是吗？ OK，虽然忘记了，哦，baby 这个人可能绘画识字，识字，老人痴呆。OK，but I think it's this one. So that's why I will spend a longer time in the basic. Once you know the basic, you will learn a lot of things. Maybe just by yourself, without me also can learn. Okay, so I will focus more on basic in my class. Does that make sense? So 那些基本的东西一定要你会啊，你就可以去读其他的书，对吧？你其他书你就看得懂，甚至其他老师的话，他可能讲的不是很好，but then 你会有一个 picture 知道说他要表达什么，对吧？
而且我都一样，对，是有学，
不一定是刘杰，就是我 whoever 不是老师也可以的，就是你对话的人，你会觉得你会学到一个程度，会觉得说，哎呀，我知道你讲什么啊，但是你就是讲的不是很好，等你讲给他听的时候，对对对对，我就是在讲这个东西啊，这样子，你能够做到这个，就代表你的理解力已经是 top 的，你可以从一个很碎片的东西知道说这整个故事是什么，OK，明白？有一点类似像算命师的，其实给他一点碎片，他就开始讲这个人，OK。So actually 算命其实是蛮 logical 的一个东西，反正当然有很多神棍呢，就乱讲罢了。But then 它是有个 logic 在的。In the end, I mean 算命 is just like a big data 的，就是对吧？他给你一大堆指纹，然后给你这个人发生过什么事情，哦，好像大部分的指纹都配这个事情，哎，哦，你有这个指纹，你一定会发生这个事情，哦，big data analysis，明白吗？嗯，OK，very scientific。Okay, so let's continue. So maybe we recall what we did yesterday. You still remember what's the big theorem we did yesterday? 什么 theorem？好像只有做一个 theorem 吧？啊，什么名字？Yes. Okay. Intermediate value theorem. Okay. So what's the intermediate value theorem? What is the assumption? Let F be 什么？你觉得不舒服？难怪你坐后面。Let F be what? I mean 这整个课我们只管 F 是一种东西吧。Continuous, very good. 所以讲啊，是谁讲？哦，OK OK，声音从那边来，OK，没有注意到。OK，let be continuous. Then on a closed bounded interval, very important. Okay, almost we only care about closed bounded interval now. So if you consider FA and FB, let's say FB is higher than FA, then all the value in between FA and FB, right, that exists as such that S is inside this interval and then achieving the intermediate value. Okay. Okay, makes sense. Okay. So from here, we also can deduce for the other case. Let's say FA is higher than FB. Also works. Okay, also works. We also can do that. Although we just prove for one side, but then I challenge you to prove the other side. Okay, use similar proof. Okay, similar proof. Yeah. Who is doing this week? Lecture notes. Lecture 13是谁？谁管的？谁打 lecture 13？哦，12。谁打 lecture 12？谁打 lecture 12？lectures. Okay, I posted up Hua Yue one, Chen Yu one, I also posted out already. Actually,
Fusion one also posted out, although you guys haven't had the summary and question yet. I already posted because the main body is kind of complete already. Okay, so there are at least 3 of them here. All of you can try and have a look. If you have any comment, you can let me know or just let that person know so that he can or she can do a correction. Okay, so we got 1, 2, 3, 4, 9, 10 here already. Yeah, so if you have updates, so send it to me again. Okay, please send it to me again so I can update. Okay, so there's few person haven't sent it to me yet. Few person like 海涵 haven't, 本玉、洪杰、陈伟、Jinghan, have you done? Finish? Not yet. Okay, waiting for your latest one. And then Yuhan and Helen. Okay, so you can try and prove the other version of the intermediate value theorem in Seng. Okay, kind of repeating the proof, but then you need to adjust the inequality. Okay, yeah. Try to do it. Okay. Right. Okay, so today we're gonna use this. I think we are using this, if I'm not wrong. So I'm gonna use this to prove that a continuous function will attain its maximum on a closed bounded interval. Okay, so what does this mean mathematically? Yeah. So again, let f be continuous on a closed bounded interval. Then, first thing is f is bounded. Bounded means what? Yes, the value of f will be bounded above and below. Okay. Second, there exists an x in AB such that fx equal to the sup of fy such that y is in AB. Okay, so if you look at this sup here, means what? You look at all the x value in AB, the domain, and then you apply f because f is bounded, right? Okay, so you look at the sup, and this sup is achieved by your f. Make sense? Remember? Okay. This is not always true. Let me give you an example. Yeah. 1 over x. This is not always true though. If you consider 1 over x, maybe negative 1 over x. Okay. Correct? No? Negative 1 over x. But I just care about 0 to infinity. So let's zoom into this part. Okay. So the f is going up, right? But then you learn that there's an asymptote for this graph, right? The horizontal asymptote. Meaning what? Meaning it will achieve the 0. I mean, not achieve. Go very close to x verse, but won't go beyond it. So actually 0 is the sup. But then there's no value such that 1 over x equals to 0. Okay. So the point here is what? You can see that the domain we take here, right, is not a closed and bounded. It's not closed and bounded. Okay, so once we make it closed and bounded, then your function is also bounded. You just pick a chunk. Then this only apply to continuous function. If it's not continuous, then it might not be true. Okay. So continuous plus this closed and bounded condition, your function becomes bounded. Does it make sense? Okay. So let's see how we prove this. See how we prove this. Let's prove this. So first we will prove that F is bounded. I guess we will just prove bounded above, bounded below should be similar. Okay. So suppose that F is not bounded above first. I suppose for contradiction. So that means what? That means this set here is not bounded above. Meaning the value is not bounded above. The value of F. Okay, if it is not bounded above means what? In particular, we can create a sequence. Okay, for any n in n. Okay, there is this point inside AB such that fxn will converge to is greater than n. Okay, so you can see that in this inequality right here, right? Why I need n here? Because I want to create a sequence that's greater than every. Okay, create an n such that this sequence have value greater than value greater. Because it's not bounded above, so you must have large number inside. Okay, so the claim is the sequence fxn will diverge to infinity. Well, this follows from the definition, right? But moreover here, there's a stronger statement. Actually, every subsequence of it also diverge to infinity. Okay. Maybe I won't write down this one I wrote in the text. Maybe I can talk about the idea first. So if you have a sequence that diverges to infinity, every subsequence must diverge to infinity also. This is a bit different from the convergent subsequence thing. Maybe you diverge, maybe you have a convergent subsequence. But then if you diverge to infinity, all the subsequence must also diverge. To infinity. Not diverge, diverge to infinity. When everyone need to go up. Maybe I use drawing to show you. Yeah, diverge to infinity, maybe something like this, right? When you diverge to infinity. Okay. But let's say you have a subsequent don't diverge to infinity. What is the picture looks like? So subsequence meaning what? You are picking some of the point, right? So that they don't diverge to infinity. Can you see what happens here? And this subsequence should continue. Also, infinitely many of them. So can you see that this sequence is no longer diverge to infinity? See that? Can you see that? Or diverge to infinity meaning after certain big n, everyone have to go up. But then this one, someone still staying down. The whole thing. Some push it. Understand? Okay. So unless this one also go to infinity after a certain n, but then this means that this subsequence also diverge to infinity. Okay. Otherwise, the original sequence won't diverge to infinity because there's someone that diverge to some other place or converge to some other place. Okay, makes sense? Yeah. Okay. Try and write this down. I already wrote it in the notes, but then this is the idea. Okay. Let's take this claim. Okay, we take this claim. However, note that how do we our sequence? This sequence here is living inside the closed bounded interval. Okay, meaning what? By Bolzano-Weierstrass theorem, there exists a subsequence. Yesterday we mentioned about this, right? As if a subsequent yn of Sn which converges to some point in the closed quantum interval AB. Okay. Okay. So now we have yn converge to y. So by continuity, we have Fyn converge to Fy. In particular, what does this mean? This means that Fyn is a convergent sequence. Okay, obviously subsequence. So meaning that this sequence here is bounded. Okay, so meaning what? You found a subsequence that is bounded. But then just now we claim what? No matter what subsequent you find here, it should be not bounded, diverge to infinity. Okay, so here's the contradiction. Does it make sense? Okay, just now we claim that every subsequence should diverge to infinity, but then by Bolzano-Weierstrass and continuity, we found a subsequence that is convergent, hence it is bounded. Yeah, I think we showed this last time, right? Every convergent sequence is bounded during the Cauchy stuff. Yeah. Okay. Makes sense? So I said that they all have to diverge unbounded, but then I found one bounded sequence, subsequence. Okay, so contradiction. So hence F is bounded above. So you can imagine bounded below also proving like this one. Okay, suppose there is no bounded below, and then you create a sequence that's diverged to negative infinity, and then you claim that there's no subsequent of it. Every subsequent of it has to diverge to negative infinity, and then you got no constant, it's bounded, and then so that's like a duality asymmetry. Alright, good. All good. Okay. So next, second part is we want to find. Now we want to find x in AB such that fx is the sup. Okay, but then sup should exist, right? Because this is by the completeness axiom. Okay, but then now we need to find an x such that we can achieve the sup. So by completeness axiom, sup x exists because it is non-empty and bounded above. Okay, so how on earth we're gonna find this sup? I mean, like found this x to give me this f. Huh? Shape monotone and then I see. But then your f might not be monotone. I don't have this condition. You cannot simply add condition, Otherwise my theorem need to change. My theorem will just look for continuous monotone function. But then the theorem didn't say monotone. Otherwise, if you just prove for monotone case, you need to prove for non-monotone case. Yeah. So here we should be able to prove everything in one go. Okay. So let's do this. So now let's construct sequence in S. Okay, what is S? S is this set of image of f here. Okay, set of image of f. Okay, so let's construct a sequence in X that converges to sup X. Okay, so meaning what? Meaning we're gonna have a sequence. We will start with the domain term because it has to be f of something, right? Okay, f of something, and then that thing you use to index it. You index it. So sequence of point in AB such that fxn will converge to sup x. Okay. Do you know how to construct this sequence? You know how to construct this sequence? Using the sup property. Sup property says what? I think you do it in your assignment too, actually. Sup property says what? For every epsilon, usually this definition, right, it make more sense if you draw it. If you just remember it as epsilon, the epsilon, this epsilon kind of useless. Okay, you need to understand this epsilon as some number, okay, some distance. Okay, so your sup x is here, right? Okay, for all epsilon greater than 0, and if you consider sup x minus epsilon, you will have some element from the set that is greater than this number. So maybe we call this fs1. Okay, so how do you, from here, from this stage, how do you create a sequence that can converge to sup x? What do you think? From one epsilon, I get one fx. Then fx2 should be where? Yeah, if I want to converge. Depends where it's epsilon over 2, right? But then surely we want to get some epsilon that is less than epsilon, not epsilon 1, actually less than maybe sup. Okay, more precisely, you can take sup x minus epsilon 1. But then if you just have epsilon 2, I think it's fine. Epsilon 2 is fine. Epsilon 2 less than epsilon 1, sorry. That's what I meant. Sorry for the confusion. Okay, so maybe you can take some epsilon 2, smaller one, and then found another fx2, and fx3, sf4, sf5, sf6. And then you can get a sequence that's very close to the sup. Makes sense? Okay, so you can create a sequence by looking at different epsilon. Okay, and then find fxi such that fxi is greater than sup x minus epsilon I. Make sense? Because this will imply that sup x minus fxi is less than epsilon I. Okay. Make sense? Okay, so this is how you create the sequence. Why I didn't write this sequence down, because the form of the sequence is not important for this proof. Okay, but then you should know how to create it. This is one of the way, one way to do it. Okay, so since again, sorry. So since we know that xn is in the closed interval AB, by again Bolzano-Weierstrass again. Theorem. That exists a subsequence yn of xn that converge to somewhere, okay, such that yn converge to x in M. But then again, use continuity at the same time. Fyn will converge to fx. Okay. But what do we know, huh? But what do we know? Xn is a sequence as a convergent subsequence. Okay. I think last time we showed that if you have a convergent subsequence and then your sequence is What's the statement again? What's the statement that relate convergent sequence as the limit of the original sequence? You still remember?啊 ？link sub 不是，好像要在前面一点。Let me find it. Convergent subsequence. Convergent subsequence. Okay, this one is Bolzano construct. If a sequence converges, then every subsequence must converge to the same limit. Okay, this one. Still remember? We prove this. If a sequence converges, then every subsequent must converge. Okay, otherwise your original sequence won't converge. A bit like the idea of the diverging just now. If you don't diverge together, then you won't. Okay, so we're gonna use this. So at the same time, Fyn converge to Fx. But we also know that to reconstruct Fxn, right? It converges to. This is how we construct it. And Fyn is a subsequence. Okay, it's a subsequence of Fsn. Okay, that converge to Fx. Okay, so the original sequence converges, the subsequent also converges. They have to be the same limit. Okay, so this proof that suit x is equal to Fx. So if you think about this proof, right, where did you get the Fx from? Who give you the Fx? I mean, what theorem give you Fx? What theorem give you the existence? Which theorem? Right? What theorem give you this Fx? Sorry? What theorem give you this Fx? Intermediate value theorem? No way. Did I mention intermediate value theorem anyway? Continuous. Yeah, sure. Before continuity, Bolzano, Walsh. Yeah. Okay, this X you obtain from Bolzano, Walsh. And then continuity tell you that it is this Fx. Bolzano Walsh give you the existence. 明白吗？如果你没有这个 Bolzano Walsh，你就找不到这个 X。So what is Bolzano Walsh? Every sequence in the closed bounded interval has a limit there inside the. OK 吗？明白 ？Any question？ 明白 ？OK， 这个 Bolzano Walsh。Oh, sorry, 我讲错了。Bolzano Walsh means that every sequence in a closed bounded interval has a subsequent that converge. Yeah, original sequence 不一定 converge, but then there's a convergent sub. Okay. Yeah. So you could imagine, this subsequence can be different, 懂我讲什么吗？可以不一样。还记得那个 -1 的那个例子吗？我的 convergent sequence 可能是 converge to 1，可能是 converge to -1。所以这个 Bolzano Walsh 给你这个 x 可以是不一样。这个跟你在 Calculus 1的学的东西应该 match up 吧？因为 maximum 可以 achieve in different places， right？ 可能有不同的 maximum 地方有 maximum， 对吧？可能有在这两个不同的地方都是 maximum。 OK，so boson versus 可能给你这个，可能给你这个，不知道，都有可能。Make sense？ OK。So one comment is one comment is if I change this to open interval, right, it might not work. Can you think of why? So I make it open, then 不一定找到 maximum 点。Can you give me an example? Okay, could be one of that case or like 1 over x case, right? There are actually more simple cases. They are also increasing, right? I mean, yeah, increasing, right? Yeah. They are more easy one. So meaning like you just don't have that point actually. 就是没有那个点在你的 set 里。Yeah. Does it make sense? Okay, yeah, because the soup is this point. You cannot pick soup here because there's another point here then. You remove the soup. You can remove the soup from there. Okay. Another way to prove this, you can use a nested interval theorem to prove this. Okay, in that proof, it will be more constructive. So more constructive meaning you can, for example, the example I gave you just now, right? Where is it? This one. You can do a nested argument, okay, so that you can really pin down which A1 or A2 you are looking for. Okay, just now Bolzano-Weierstrass just tell you that there's one subsequence that converges. Don't know which subsequence. But then if you use nested interval, then you can nest it around somewhere that you can find the soup. Okay, so try and write down this proof if you can challenge us. Okay, write down the nested interval. Okay, nested interval you might need to nest it around this soup vacancy. Okay, then the nested interval will tell you that, oh, there is a point inside this nested. That exists at every interval. And this one will be equal, the value of this will be equal to the soup. Okay, so this proof will be constructive. Okay, constructive proof means what? Means that it really tells you how to find it. The Bolzano-Weierstrass proof is not constructive. It just tells you that exists. Understand? I don't know how to find, but there is one. And then nested interval will tell you how to find it. Okay, because you need to nest it around some places, and then reach this. Okay. Cool. All right. So altogether, what we have is what we call the extreme value theorem. Extreme value theorem says that a continuous function on a closed bounded interval will attain both maximum and minimum. Okay, or in other words, there exists point CD in AB such that for every point in AB, Fx is squeezed between FC and FD. Okay, so meaning D, okay, sorry, D. Meaning if you draw any continuous function, right? Okay, and then you look at the closed bounded interval, then it surely has some lower bound and upper bound. And then moreover, these are achieved by your function. Right? You can find the highest point and the lowest point. 对哦 I think 这个世界里这个东西是对的，对不对？你看一座山，看一座 building，你都可以看到一个最高的一个最低。Because they live inside a closed bounded interval. 对吗？可以量的嘛，对不对？世界最高的建筑物是哪里？哦，
不知道哪个城市呀？杜拜叫什么名？发什么发？发什么发？有人知道叫发什么发吗？不知道，全部不知道。这样我开给你们看。啊？Yeah, highest building in Malaysia. Sorry, in Malaysia. Yeah, 第二。Let me. Burj Khalifa. Yeah, this one. Okay, this one. Yeah, so when people when Medica build it right, actually they don't promote it as a second house. They actually build it very quietly. Because there's a very controversial structure. Is this really counted as a part of the building? Not sure, but then you can go and do something about that. But then world still recognize it in the end. The world recognize it as second. But then Malaysia didn't say that we are second here. World recognize it. Yeah. So you can find the highest and the lowest point in the surf. But then the lowest point it's also controversial. Because no one really get into deep down in the earth. Maybe did you learn science that say that the earth is consists of the magma, right? The magma, the 岩浆啊，有没有听过这个 theory？ 有吗？你们课本有没有？我以前课本是这样啊，我不知道现在课本是有没有岩浆啊？地心是岩浆做的，听过吗？越很热，你挖下去很热，听过啊？有听过不是？反正 that's just theory 哦。That's just theory 哦，没有人真正挖到最下面，里面不知道是什么来的。其实 ，exactly, this is the point they took it and then they think that is a who knows there's something deeper inside， 对吧？不知道。If you go and look at documentary like Russia， 他们真的有挖到地底下。挖到一个程度，他们不敢挖，你知道为什么？他们现在一个很规则。我没有要吓你啊，都市传不是都市传说，是事实，只是怎么 interpret 它是个都市传说。
那个声音
啊，
怪难啊，太吵住了。
什么叫
那个声音，这个声音。
好像声音啊，是，反正有声音啦，有声音，打不到什么声音。说都市传说是说那个是个恶魔的声音，都市传说啊，反正它真的有声音，不知道什么，他们不敢挖下去，他们挖一个程度，好像挖的最深的是 Russia， 还有一个地方也很特别啊，南极
也是进入
South Pole 不属于任何国家 ，No country can own it。
是讲了一个差不多。就3种差不多，magnetic， 然后去它
好，yeah，那个地方也很神奇。
South geomagnetic pole，
Right. In stream value theorem. Okay, maybe break here. Okay, let's break here. OK 啊，等一下讨论，还是现在讨论？现在讨论啊 ？OK 啊，也可以，也可以讨论。OK， 等一下再拍给你们，我们讨论答案先。
我没有看到有讲的，
啊 ？I mean 我有题目啊。I mean like 等一下你们来看你们的那个分数啊，我们可以看到。
像我们
不用了，没有时间。下次有机会再给你们。OK。
So first, why can you pick n in n such that a big n in the natural number such that the natural number n such that 1 over n less epsilon? You can do this for every epsilon. Okay. So does this work for epsilon less than equal to? So what I want you to answer is Archimedean property. Okay, if you write this down, then you'll get most of the marks.
Rational.
Rational? Okay. So for every epsilon in the real number, 1 over epsilon is still a real number. So by Archimedean property, you can get 1 over epsilon less than n. This will imply that 1 over n is less than epsilon. Okay, but does it work for negative epsilon or 0 epsilon? 看到吗？有没有一个 e over n such that 它是 negative？没有，没有哈。It might not work for epsilon less than equal to 0 since the existence of this one will lead to 1 less than equal to 0. Okay. But then I think a lot of you think of this instead of this. Because you think that this is equivalent. But then this is only equivalent when epsilon is greater than 0. Okay, so if it's less than 0, then you have to solve the inequality. Okay, not just you, few of you actually. Yeah, fall into the trap. Okay, so you didn't realize that in this step here, we actually have epsilon greater than 0. Okay, so that we can do this. Actually, you cannot do that. Okay, actually, you cannot do this for negative. Okay, this all okay? Okay. Next, explain the density of rational and irrational. So basically, this is just saying that every two real numbers we found a rational and irrational number. 怎么？
我讲那个 irrational 比 rational 多，因为你有 one over two 对，你可以 set one over two，one over set two，就它这样加起来会比较多，这样算 explain 吗？irrational 比 rational 多是这种方法。
Not really about 多少多啊？
就讲 irrational 比 rational 算把它更 density。
因为它跟
density 就是谁比较多，不是？
不是
啊？
不是啊？
不是
？Density is like 密集。
对啊，就是密集啊，就是谁比较越多越密吗
？Implication maybe。But 密一定要多还是怎样？看你的空间怎样吧。我如果是 discrete 的空间，我一个人我都很焦。我一个人我都很焦，也就是说看你怎么 define density。呀，所以就是在什么 topology 啦。But then the density will refer in the lecture notes。如果你看我那边挂号的话，就是这个 statement 来的。But then 在这个班我还没有 define 什么是 dense 啊，因为我们没有 topology 啊 whatever，metric space 啊。I mean 有啦 ，but then like no point to talk about those things first 啊。But then 如果你有興趣啊，你去拿 general topology 啊。
不要坑我，
不要看你，不要看你，
不要坑我，
我不要坑你
啊，意思哦。
OK，sorry， 我没有只坑你。没有的 ，OK， 没有啦，就是说如果 if you have chance to take general topology 啊 ，we will define a dense there, and then you will show that this density will imply that density will imply this density. So 这两个 statements 是 equivalent, so this is about density of rational and irrational. Okay, but basically it's every two real numbers you can find a rational and irrational inside there. But then some of you try to make this simpler. You say that every two rational you can find, every two irrational you can find. But how about one rational, one irrational you can find or not? Actually you can. Okay. 明白吗？随便拿两个 real numbers 中间你都可以挖到一个是 rational， 一个是 irrational。
那个语法
什么？
那个语法。
等下你看一下有没有。如果不够分，来5分钟。OK。Good。第三题哈，第三题 actually 就是So my hint is to write down the definition of convergence of the sequence. So suppose Sn is the sequence and prove that 这边要有一个括号，没有括号？Okay. Prove that if modulo of xn goes to 0, then xn also go to 0. So you basically Okay, write down what this Sn go to 0 means. That is modulus of Sn minus 0 less than epsilon. Also write down what this means. This is just absolute of absolute Sn minus 0. But then, what is this? This is just absolute of. Okay, maybe I add one more step here. Absolute of Sn. This is not the norm or the length. It is an absolute of absolute. Okay, but then absolute of Sn is actually absolute length. You don't prove this, it's fine, but maybe you can prove it. Okay, you can prove it. So I have a lemma, short lemma here, but I won't count this. This is a bit extra. Okay, so you prove that for x positive, they are the same. For f non-positive, also the same. Okay. Yeah. So basically, it's the same n you pick. Okay, it's the same n you pick, such that this converges. This converges is also converges. Okay. Yeah. I think we got like 2 to 3% got full of this. Yeah. So it's actually doable. Usually, if you look at the quiz, my solution is very short one. It's to test your understanding. You know what's going on or not. Yeah. So if you write too long, that means got some problem already. Because this quiz is meant to be short. Yeah. Yeah. Okay, any question about this? Okay, maybe there's one problem here could happen. There's some ambiguity here. So maybe some of you might think that, oh, I want to pick an n such that it is true for all epsilon. You understand what I said? You understand what I said? So maybe I write down 2 versions. You can compare. Maybe I write a third one. Okay. Can you agree that these two is different? Why? These two are different. Second and the third one. They are different. Why? How are they different?
It's different. That's
Why is it different?
in this case. The first one epsilon is dependent on the big N bar. The second one big N is dependent on the epsilon.
Can you give an example where like these two demonstrate different things? So second says what? You need to have an n that works for all epsilon. Is it possible or not?
No.
Why? Why is it not possible?
If epsilon is 1 over 2n, then doesn't work.
Right. So you just simply pick an n. Okay. And then I'm going to show you that there is a epsilon that it doesn't work. Okay, but then this is different. You fix epsilon first. Only you start and find your n. But then I write in this way. This means which one? Which one you mean? Kind of tricky. Kind of tricky. 我没有教说你这边又放一个 quantifier， 后面又放一个 quantifier， 有吗？没有教过哈，没有教过。But then most of you 会 understand 这个，因为我们班上是这样的。But then what am I really doing here is actually I have a bracket here. Okay, I actually have a bracket here. So meaning when you read this, right? So I pick an n such that this, oh, and then I check for all absolute. Okay. This is a bit like what? A bit like some people will write. Okay. Some people, instead of they write for all n Pn, right? They will write Pn is true for all n. Yeah, this is a very common writing. 明白吗？ For all n Pn, but 有时候你会看到人家是写 Pn is true for all n。
这种讲话会发生有在言语相关的发言的时候，就是你没有其他讲的 this 就是对啊 this
Okay. Well, I mean, like you can put other quantifier, right? I mean, like you could like you can like yeah. Sure. Definitely. Then
到中去。
倒转句，倒转，yeah，倒转句，yeah，倒转句，yes，yeah，倒转句，yes，倒转句，yeah，对，OK，有问题吗？还有问题吗？没问题。OK，没问题的话，then we take a break. Let's break 10 minutes. Break 到106. Then you can get your quiz here. Okay, let's break until 06.
你看我吃，你做到前面的部分发了。做到这里发了。先拿去。你看他放中卷还是？我重点在下面，就是哪边？哦，这个他说的是你的那个你涉及到的个的底，就要画重点哦。他主要是要写这个句过来，好别分。Yes.
哎，上个班我没有在。上个班我没有在。他等下再回家。哦，他回家。他上星期没有回。哎，他们今天有打球吗？我不知道。他们有没？谁哦？哦，小潘也有打。
我没有打，
我也是不要打累。对，他今天可以打，就我不能打。不是那个小潘每次是拜四打不了。
拜四还没打。
没有啊，他平时拜四都没有讲出来。有啊，没有。
我是知道你今天不要打了，因为你没有，你今天没有穿那个。
我昨天也没有问，我昨天也没有问。算了啊，我回家做了。还没来，还没来。去就自己做东西。
你回一个家要很多钱，是吗？
啊，
你回一个家不要注意。
确实，如果回那个真的家的话，要坐飞机。用 MA1 来看新闻
你是哪个 IT 的上？
，IG 新闻。
是 mathematics 的 analysis 的，是 news 的。
我们 MA1 要有用一点，
我都没。
来看新闻。那什么讲？有问题吗？你没听课？
存在一个和存在无数维。
没有题，没有题啊。来50个存在一个这样，然后就做。
对不对？
哦，没有，我的意思是你 between 我 between 要 between 两个 real number，就说它可能一个，比如说一个 rational 一个 rational 呢，你还可以找
啊也可以。
啊，也可以，反正你没有写不是？
啊对。
对啊，你没有写，对啊，你没有写啊，你只
整句话都是。
你写出了选择，没有错啦，你没有写完整。对对，你是写了一些情况出来。
还差一个图片。
对啊，mix 哦，就是一个是 rational 一个 irrational，因为你的 real number 就这两个情况。
我到时候寄到款哦。
什么叫记到反？
第二到时候寄到款，就是我两个东西我那个就是我不是那个
哦，一个旁边有两个，你是说？
我
个旁边
我寄成irrational跟irrational之间
irrational 跟 rational 之间
啊，我寄成
那个是其中一个情况
啊。
对，
我知道。
它全部都可以。好的，yeah。
真的会像这个会西洋，会像会西洋。
我觉得
还是很多人都
会有 true and false 这样子的东西。
跟很多人一样，还是跟会西洋？
应该跟 tutorial 吧，
你是要透
跟 tutorial。
有没有什么？我们今天 Algebra 的老师来
说说看，
他有给 tips，
怎样的 tips
就是讲有考
没有什么啊？是哦，这题出什么？这题出什么？这题出
啊？
啊？
你觉得你需要这个 tips？
有的话肯定是最好的。
确实
不然你问一下啦，谁不要？
谁不要？谁要的举手。OK，好。等时间越靠近，我会越给越多点。这样子。trailer 吗？你太快放 trailer 出来，等下人家就很险这种。
这个才更有期待的感觉啊！
先跟你讲大方向，你去读先，然后再跟你讲什么更重要，越来越重要。一般也是我要决定到底什么，再跟你讲。不予置评。
我准备提升。我准备。
Hello to everybody. Thanks.
你们的那个 attendance 啊 ，attendance 我现在开啊，OK， sign in 了。是不是又卡了？好像。不要开了，给我拍个照，我回家自己点。这种 Shopee delivery 拍的。有没有拍到全部 ？OK， 好像又蓝又瘦了，进不去了。OK， 我们来看个时事新闻。用 mathematical analysis 来想一下 logic。 。
还最近有什么时事？非常重要的事情。
我那个凤凰山，
晚上是什么
就是那个
？What's that？
是来自马来西亚，
啊
就是它是一个地方，然后有两三个成员，它是这样啊，
啊，OK，这么惨，我还没有看到那个。
然后那个凤凰
an honor like few have ever seen before. And I think I was particularly impressed by those children. They were happy. They were beautiful. The military is obvious. It couldn't be better, but those children were amazing. They represent so much. And I know they represent so much to you. You and I have known each other now for a long time. In fact, the longest relationship of our two countries that any president and president has had. And it's to me an honor. We've had a fantastic relationship. We've gotten along. When there were difficulties, we worked it out. I would call you and you would call me. Whenever we had a problem, people don't know. Whenever we had a problem, we worked it out very quickly. And we're going to have a fantastic future together. Such respect for China, the job you've done. You're a great leader. I say it to everybody. You're a great leader. Sometimes people don't like me saying it, but I say it anyway because it's true. I always say the truth. And I just want to say, on behalf of all of the great delegation that we have the greatest businessmen, the biggest, and I guess the best in the world. We have amazing people, and they're all with me. Every single one of them. And we asked the top 30 in the world, every single one of them said yes. And I didn't want the second or the third in the company. I wanted only the top. And they're here today to pay respects to you and to China. And they look forward to trade and doing business. And it's going to be totally reciprocal on our behalf. So I really look very much forward to our discussion. It's a big discussion. There are those who say this is maybe the biggest summit ever. I don't remember anything like it. It's, I can say in the United States, it's people aren't talking about anything else. But it's an honor to be with you. It's an honor to be your friend. And the relationship between China and the USA is going to be better than ever before. Thank you very much. Thank you.
Okay. Did you realize there's one part he said, oh, you are the great leader. If you know about the relationship between US and China, they always condemn each other. Okay, this is the background. But then at the summit, he said that it is a great leader. Then he said, what? I said it because it is true. 通常你会觉得这样子讲的时候，哇，你很帅，你很美，你会觉得他是在拍马屁。可能你很帅，你讲他很帅。But then in this kind of level of talk 啊，就是这种高级的场合，他们要骂人就是骂的，讲你好了，你就是好了。我们就是讲事实吧。数学也是一样，对的讲对的，错的就是错的。我不会因为你这个好，然后你那个不好，我就觉得可以了，该过他了，没有了，不对了还是不对了。他出去外面还是骂他的，他也是讲习近平哪里都不好，这个不好，那个不好。习近平也是讲这个特朗普那个不好，那个不好，一样的。本来好的东西我们还是要 compliment。你有没有遇过有一种人呢？可能你讲了他过后。然后你讲，其实没有啊，你这个派也是很好，他就觉得说你在讲，你假讲不好，这样的人就很难讲话了，你讲不通了，你骂他又不可以，你称赞他又不可以，你啊很难讲话，这种人不能沟通。说一个点就是 we have to be honest to ourselves, okay, honest to people, honest to ourselves. 他不要听是他的事，那个天为什么？我管不了这样
叫天的，
叫天成，
叫我
啊，叫你来回答，叫你，我下次叫你讲话怎么？Actually 还有一个很interesting 的 post， 再学给你们一个，也可以扯到 MA1 的。不要讲扯啊！可以，可以 ，because it is true. I said it because it is true.
，it's not 为了拍马屁，好了。I mean 啦 obviously 有一点拍马屁的成分啊，你要讲一点好听的话，你不能在人家前面的，哇，然后你这样，人家把你请出门了嘛，对不对？反正问题是 ，we also speak of truth 啦，我不可以随便讲你好，你什么都不好，就讲你好，对吗？
你为什么信特朗普
啊？
你为什么信特朗普？
我没有信啊，我信对的东西吧，我没有信特朗普。I mean 我也可以信习近平啊，下次学习近平给你看。哎，by the way 啊。Chinese student 会不会 offended 啊？因为有些人会觉得like，他是我们伟大的领袖，你不会这样子讲啊？什么？
哔哩哔哩那边反串的，你不可以直接讲他反串。
哔哩哔哩那些是中政府 ban 了是吧？
没有。
对，
你在抖音上面可以看到很多那种你半夜3点，
你要反串，就是你不可以直接骂的，他就简称他 AI 就行了。
OK，by the way，如果你觉得 offended，你可以给我知道啊。但是我绝对没有要侮辱你的伟大领袖。
你养一下。
OK，
觉得 offender 应该这人打他必在马来西亚，这应该了，这应该。
我应该，你看，曲解我意思，曲解我意思，你曲解。我跟你讲啊，有时候我是会误解啊，但是我不会曲解。OK，我这个人是很诚实啊，我不会曲解。
你刚才讲有这个语气。
没有啊，这是他们教啊，你去看新闻联播。Okay, whatever. Okay, another news is this. This is one of the vice president of the US. Actually, it got banned, travel ban into China. But then this time, right, he went together with Trump. So meaning the travel ban is lifted, but actually it's not. What happened? They changed the name of this guy.
哦，然后看到那个新闻，
Okay. Yeah. So actually, the China government changed the name of this person so that the custom won't ban him. Maybe you think very funny, but then this is also what happened in Max, right? We have the same thing that have different name. But then one name is easier than the other name. I mean, one condition is easier to check than the other condition. Later you'll see, actually. Previously, we have a sequential continuity. Later on, we'll introduce something called epsilon delta continuity. They are referring to the same thing, equivalent. Okay. But then I don't want to comment too much on the politics. I just want to tell you that there's some easy part. I mean, something you can bypass. Okay. Maybe sequence is hard to check. Maybe epsilon delta is hard to check. So depends on which one you want to use. Okay. Yeah. Actually, I have a comment on this one. Offenders 他不是他。
有色的他
啊，
还有狗的那个他，
两个他其实是一样的他。
他变的是真名，不是改那个假。他是改什么名字？
这改华语名报。
就说他不用本来的翻译的名字，他用新的翻译的名字。用新的翻译。哦
，yes, yeah. OK， 这样很好玩的，就是这些新闻的东西，你可以读一下。I thought， 哎，你们的 description 是谁教的？哎，不是 Aras 还是谁都会有一个 assignment，就是叫你们把一篇东西改成数学符号还是什么之类的 logic 啊，有吗？我听以前的 batches 有这样做啊，有吗？来，你们 discrete math 有一个 assignment 是把
不讲，我们做这个的话，他就叫我们做一个关于 discrete math。
换掉哈。
就是叫我们从一个包装里面拿句子。
对。quantifier sometimes 是比较难找到了 ，but then 这种 logic 的东西是蛮常会看到。Okay. Especially if you watch NVIDIA CEO 不知道你们知道 NVIDIA CEO 健身环的，他讲话的时候啊，他是很顺的，他有 logic 啊，很顺，你会听到很舒服。知道他在讲吗？呀，多听一点这些人讲话 ，then 你的 logic 就会顺。对，因为有时候 不是你的问题呢，是因为你的环境的问题。因为你环境生活下，你觉得这种逻辑可能对，你已经习惯了。你家里啊，你的周围啊，都是这样的，可能把 contradiction 当成一个常态，哎，你会觉得说，哎呀，我一定要有 contradiction 这样才可以这样这样这样。其实 contradiction 是有问题的，其实这意思是说你生活的环境是有问题的，反正你已经习惯了。嗯，OK，嗯，Yeah， right， you can try and think about it， 想想有没有这类的问题存在，然后你能不能帮你的周围的人、你的生活的家人，就是活得更好、更自在。
可能对他们来讲没有逻辑之最，
嗯，
方便他们无理取闹。
方便他们无理取闹。但是我觉得啦，我觉得他们也会有某种程度是觉得烦，但是他们没有办法，他们不知道怎么处理这个烦，所以他只能够把这个烦拿来给其他人。你明白吗？哪里知道？你帮他这个烦解决了过后，他就不烦了嘞。
讲，
你懂我讲什么吗？
知道，解决了
你会暂时性的烦 ，temporary 的烦。
那但遇到别的问题又烦了。
解决
要解决，无限解决啊！induction。
But then， 他无限的烦，他肯定我觉得背后有一个原则还没有解决。你解决到那个，它就可以 apply to 那无限的，就是你要把 PN 写下来先。你不可以 solve for ON 啊，你要把你的 PN 写下来，你要 solve 那个 PN。
加去某一个
啊，你不可以只 solve PE，你不可以 solve PE、P2、P3、P4，这样当然是无限 solve 下去了。但是你知道我们有 mathematical induction 吗？你一定要把 PN 找出来，那个 PN 啊，那个 statement that work for ON，work for 每个情况。OK， 不一定每个情况啊 ，maybe 你要把那些东西分成一些 part，也比较简单嘛，好过来一个小事情，一个小事情，一个小事情，明白吗？这就是数学啊 ，abstract 哦 ，abstract 出来看哦，因为很多人就是他一定要看到那种小小的细节才可以。反正数学是来 abstract， 我可以一次过看几个，一次过看完。OK， yeah，
你就让你自己写是吗
OK， 好 ，then let's continue with epsilon delta。Okay. I think in my previous note, we started with limit point first, but then I realized we can do it later, and also I won't do it in the test. So let's start with epsilon delta continuity first. Okay. So the motivation is this. So previously we talked about sequential continuity, right? So meaning if I have a sequence that converge to this x here, right? Then I also have a sequence on fx1, fx2, where? Oh, sorry. fx1, fx2, and then converge to fx. Okay. But then this is true for all sequences that converge to x. So meaning you can have different kind of convergence, right? Maybe you can have convergence like this. Okay. You also can have conversion from one side only. Right. 随便的. So meaning what? Meaning the thing that's close to x is very important. The thing that close to fx is also important. Okay, so this motivates our epsilon delta continuity. Okay, so let me write down the statement first. So the moral of the story is the number that's close to fx and x is very important. Okay, so Let's draw this. So let the f be a function. Then f is continuous at a point C, if only if. Okay, maybe put if. Later we'll show if only if. For all epsilon greater than 0, there exists a delta. Okay, maybe depend on epsilon. No longer natural number. It's just another real number. Such that for every x in the domain of f, so here maybe a function of this domain, such that if your point is delta close to C, your fx will also be epsilon close to fc. Okay. Shall we give an example? Okay. So let me draw an example. We draw something like this. Okay. So let's pick our C first. So we want to check whether this function is continuous here. So meaning what? For every epsilon, okay. Let's take this fc. Let's take a particular epsilon. Let's take this epsilon here. So we're gonna pick this epsilon. Okay. There exists a delta such that fx, fx will live inside this epsilon strip here. Okay. So here is fc plus epsilon. Here's fc minus epsilon. Okay. So which delta could work? Does this delta work or not? Does this delta work? Okay, so if I pick this delta here, okay, do I make sure that fc minus fc is less than epsilon? I make sure that all the x's here, okay, give me fx minus fc is less than final. Final. I look at all the x's here, okay, and then I look at all the fx here. Okay, I take the difference with fc. Do I lie inside the epsilon strip? No, right. There's someone greater than epsilon at the distance. Okay, outside this epsilon. Okay. So meaning what? I need to reduce my delta. Okay, I need to reduce my delta. For example, I could reduce my delta up to here. Right. Okay, reduce my delta up to here. Okay, so that all the fx, okay, is lying between this epsilon strip. So fx minus fc is less than. Okay, does it make sense? Okay, so I can reduce this because I don't need to hold true for all delta. It's just they exist is enough already. Yeah, as long as I can found that. Does it make sense? Yeah. So you can think of this existence of this delta as like the existence of the natural number in the sequence case. Okay, because the natural number also require you that for all the term that is beyond that n, right, it will be epsilon close. Okay, so here is the same. And any term that is delta close should be having value that's epsilon close to fc. You get the idea? Yeah. So previously we used sequence to talk about it, but now we are just looking at a range, a region. Okay, makes sense. Okay, so you can think of this delta as a tail of the sequence, because you look at the tail of the sequence, it's getting very close to the point you are interested in. Okay. Right. So, you want to see example first, or do you want to see equivalence? You want to see examples or equivalence between epsilon delta and sequential continuity? Which one do you want to see first? You want to see examples or you want to see equivalence? Pick one. Making choice is a practice also. Examples, okay. 拼接 love example. Okay. Let's look at example first. Let me show you a hard example, okay? A hard example. And then I will do this example in 2 ways. Okay, 2 ways. So let's look at this examples here. I think you can use the composite function or the product function to see that fx equals to x squared is continuous. Okay, but then now we're going to show it using epsilon delta way. We're going to use epsilon delta to show it. Okay, so let's try the first proof. Later, I will show you the second proof. So I want to show that because I say continuous, right? So this is continuous at every point. So every point and for every epsilon, there should exist a delta such that for all y in R, y minus x is less than delta implies y squared minus x squared is less than epsilon. All right. Have you tried this proof in calculus 1 before? Forget. Okay, very good. Forget. Good. Okay. So let's start from beginning then. So if you want to show for all epsilon and for all x, right? So meaning you need to fix an x first. And then also fix an epsilon. Okay, so now your job is to choose to find delta. Okay, so how to find delta here? Meaning, how do you play around with this inequality? You need to know how to play around with this. Okay, so what way to play around with this? Well, so let's do some working first. Maybe let's do working here. So how can you split up this x squared minus y squared here? Well, what's your assumption? Okay, to say that how to play around with this, you need to somehow introduce your assumption. Is there any relation between y minus x and y squared minus x squared? Any relation? Any relation? Can you obtain y minus x? I mean y squared minus y. Okay, very good. Okay, so we can factorize it, right? We call it factorization. Or distributivity, like what we discussed last time. Okay, so meaning you need to bound these two terms under epsilon. Right, you want to bound this two terms under epsilon here. You want to bound this two term under epsilon. Okay. One thing you think, what do you do? If you are in a quiz condition, I think you will directly say let delta to be epsilon over y plus x. Is this what you're gonna do? Yeah, but this is what people always do. They're already desperate already. It is, but they are desperate. They're really desperate. Okay, so Qian said, why is the problem here? Why is the problem here? X is not a problem, you know why? X actually is a constant of it's a fixed number. But y it's not a fixed number, you know. Can change one. How you change it? You know the condition on y or not? It just satisfies this property only. So it could take out any value as long as this as long as this satisfied. Okay. If it is minus x, then you are GG. You understand? Okay, if it's minus x, then epsilon over 0 is not defined. You understand? Okay. So how do we go about this? So how we go about this? How do we go about this? So how do we go about this? Huh? Someone say something? How do we go about this? Okay, before we go about this, right? Okay, let's say this doesn't work. Let's draw this picture. I always ask you to draw a picture, right? I always ask you to draw a picture. So make sure you can draw a picture. So y square, x square, looking something like this. Okay, so we care about any x's. So let's take the x's here. Okay, we want to show that it's continuous here. Well, I mean, like, still remember my format about this epsilon thing, right? We just really care about small epsilon. Small epsilon is important. But then, so we're gonna play a trick here. Maybe I'll tell you why this trick will work later. So we're gonna play a trick here. So we're gonna choose so how about use this color? We're gonna choose delta epsilon to be the minimum of 1 and this thing here. Okay. It might not be all apparent why I do this, so later I'm gonna show you why. Then you will know why I picked this, and then maybe you can even do modification to it. Okay, so actually MA is a class of creativity. So you can pick n epsilon differently. Okay, such that if I have this is true, this will imply that this xy square minus x square here, which we already split up this. Okay, then I claim that this thing is less than epsilon over 2 times epsilon absolute value of x plus 1. Okay, and then I claim that this part here, this part here, this part here is less than 1. Okay, so that I get epsilon. Okay. If you get presented something like this, how do you check? Okay, for example, you go and pick out your textbook and you read. Hey, choose already, calculate already. I don't know why. How to check? Where to start? So now I teach you how to do backward engineer. How to do backward engineer? 直接的 translate 是那个，就是从答案想上去，怎样来啊这个答案？ Okay, so you want this to be less than 1, right? Okay, so let's verify this one. Okay, is this really less than 1? Well, so if this is less than 1, what does that mean? This means that is it strictly or less than equal? Maybe less than equal here. So here maybe less than equal. So this would imply that this inequality here is less than equals to 2x. So okay. So when is this true? When is this true? I don't know how well you can play with inequality lah, but then this can be implied by. So we are 反向思考, right? So let's do it backward. So this is implied by this. And this can be in turn implied by this. Okay, so this less than 1 here, right, is the one of the delta choice. Okay. And then this implies this, I think we proved this before. This one. Do you still remember? We did this. Okay, but this how to go? Can we go here from here to here? Plus x let's try. Okay, let's try. So if I put the epsilon x both side, okay. 什么？这个要 proof？ 要看一下。哦，你讲 plus absolute value on both side 哈。啊 ，okay, one side 我们 get 到 what we want, right? But the other side 呢？ Yes, triangle inequality. Okay, so 更好，更小 ，potentially 更小。Okay, yeah, very good. Yes. Okay, so this is exactly why we found one of the delta is less than. Okay, does it make sense? Okay, so that the other delta we only pick based on two constant. One is epsilon, one is x. Okay, you cannot have y inside there. Y is not a constant. Yeah, another reason why we choose epsilon over 2 x here plus 1 is our x could be 0. It could be the case that you are checking at the 0 point. Okay, but this one will save the case. Okay, so what it means here is whenever you want to check for the epsilon delta continuity, right? Either given you any epsilon, okay, given you any epsilon, either you choose 1 as your delta, or you choose a smaller one. Does it make sense? Remember. Okay. If this number here turns out to be bigger, you choose 1. 在哪个地方会发生这样的事情？你觉得？对，在哪一个点，这个号码会大过这个号码？啊，或者你写一个 epsilon 跟 x 给我啦，它就大过1。没有，你一定要选 epsilon 跟 x 出来给我。
epsilon 等于 x 等于派 epsilon 等于110。
等下你讲，你看先
epsilon 等于
x 等于0，那就是1啊。epsilon 等于1。
哦，
我要去大啊，我要去0大。2跟0啊，2跟0 ，OK。If I choose 2跟0，会发生什么事情？ So maybe 再 draw 一次，再画一次。y square here, x square. OK， 看0这个点啊。OK， 你的 epsilon is 2， so meaning 你会看到 up to f of square root 2啊，这边 the square root 2， right? Then what is your delta? Epsilon here. So your delta epsilon 2 is picked between mean of 1 and 2. Okay, so instead of picking sorry 啊，我没有画错东西。我画错了。哦，没有，我没有画错。Your epsilon is 2, right? And then this is 0, 1. Okay, 对。Okay, good. Okay, so instead of you picking your epsilon to be 2, delta. So delta to be true 发生什么事情啊？它 actually 跑出去哦。Did you see it? 有看到吗？如果你选 delta 等于 2 哦，2是大过 square root 2吧，对吧？说 2的 f2 是什么？4对不对？4对不对？4减0是多少
4 which is greater than your epsilon 就出去啊，所以你就选 e 就好了。e 是小于随2。OK， e 是小于随2。所以你的 delta 在这边。OK， and it is surely less than epsilon。OK， 明白吗 ？OK， 可以吗 ？OK，make sense？ 有问题吗？没有，就一个是可以避免到那个，另外一个是因为我们一定是 fix， 因为我们是 make sure 这个小于yeah I mean we pick minimum of these two， minimum of these two， 对，这个感觉蛮难想到的，对，所以你可以其实 pick minimum 可能其他
因为我看到网上面是它要要小于你的这个表达，然后网上写的表达是小于你这个表达，比如说 take minimum of e， 然后 comma x 乘以 x 加 e， 然后把它乘以一个或者是。
对，我们这个就
因为我是要从很上这一个，
我不是有等于这种比赛，还有什么不满？
因为不好意思说，就是说，你这个有另外一个方法，比较麻烦一点。
我刚才都跟你讲 ，MA 是一个 creative 的课啊，只要你对他想要做就好。
因为你考试的时候怎么可能会给或者这个人填话语这个表达？
没有，他之前也是讲过，就是你的抽号纸就是用来去找怎么样去得到这个目的。
对啊 ，exactly 啊，
好像这个目的给我们啊，就是你有一个，
就是看你怎么去猜这个东西的，你怎样去包你这些东西。OK，
最后出来。
像你那个晚上的那个原来汉堡不是也是这样的？
不是，就是他们就是因为你这个，你还要去 check 它表达exactly 等于那个东西的时候，它也是问的，就是你还要选那个，你看他们网上其实也在，比如说1/2 of million of e comma epsilon 除以2x 加1的之类的，会有一个人在前面有一个公式在前面是乘以这个概念。
没有用啊，你还是要 argue 这个 part 怎么都不见啊，你还是要 argue 这个 y cos x 的 part。If you gonna argue this, then you surely need to relate them. Otherwise, 你怎样 argue？ 你不能 argue。
等一下我给你看。
OK， 你等一下给我看。But then you surely have to argue。你一定要跟我讲那个 absolute y 加 x 怎么会不见掉啊？怎样包那个 term 啊？你还是要跟我讲怎样包那个 term。不管你怎样做 ，OK。But 还有一个更准确的做法，更准确的。如果你有看到我的脑的话，你也可以放一个更准确的哦。刚才 maybe 齐安提到一个点就是，为什么你要选1啊？你可以试下选其他号码，看看会不会 ，then 你的另外一边就会长到有一点点不一样，另外一个 choice。OK， 你可以 try 其他号码，你可以 try 其他号码会不会？这个 E 没有特别的地方啊，这 E 没有很特别，你可以选其他号码。OK， but then maybe 有一个包呢 ，you should try. I invite you to try it. Or you can do it the other way. Should we? Let me just write down for you. Second way. 你不要问我怎样想到这个东西啊。But then 我会说你怎样可以算到 ，and then maybe 你就可以想为什么我可以这样子做。这个。如果你不想 minimum 的话，写这个准确的，写这个拿去 verify 一下，看下会不会。Okay, so maybe I go verification in my notes. So let me show you. 看一下能不能快。Okay, here. Okay, so here is the control of the boundary. So how do I control y plus x here? I make it become another y minus x first. And then plus 2x.
as I told you, right, x is a constant. But we can always estimate y minus x using delta. Right? Okay, so we got two parts. That's why there's a square root coming in. Okay, and then turns out that this bit of constant is over this bit of constant is less. I think you can show this. So it is less than absolute. Exactly the same. It's exactly the same. Okay, turns out to be the same. You go and expand this, it turns out to be the same.
为什么直接等于？
哪个是等于？然后它好像是一样的，上面跟下面
啊，
有一模一样。你说错。
哦，那个，哦，对，哦，就是他最后没有，我之后这个
哎，我都写错。没有，那个是 x， 好像是 x 会跟对，我觉得turns out。如果你要问我怎样做这个 algebra 的话，maybe 啊，你要 set 这个是 y 来的，然后 set 这个是 y，and then 你要找这个 y 咯，turns out 这个 y 长这个样子。
很简单，那个印象。
没有啦，我是说你如果问我怎样找这个啦，你就 set 这个东西是 y，and then 这个东西 fix 嘛，这个东西 fix 嘛，所以你就 y square，and then come up with this y 咯。
这个我先知道。
Yeah， 可以吗 ？OK。这个 delta, if you look at this delta, it's very interesting. If you look at this delta, just now I say that delta usually will depend on epsilon, right? But in this case, this delta actually depend on x's. So meaning what? If you pick a bigger x, this delta will become smaller. If you pick the smaller x, this delta actually become bigger. Okay, so there is a version of continuity where this delta doesn't depend on x, okay, which we call uniform continuity. But then this one depend on x and also depend on epsilon. Okay, depend on where you pick. So there's a property we're going to see later is x squared function is not uniform continuity. It's not uniform continuous. Okay, the continuity is not uniform. Yeah, you cannot use the same delta to control at different points. Okay, if it's uniform, then you can use the same delta. Okay. For example, you can imagine the linear function is uniform continuity. Because you can see that the way they gradient. Yeah, you can think of gradient. One way. Okay, I think we don't have time to show equivalence. Maybe we show equivalence next time. Okay, so our exam will
exactly.
啊？
准确日写的。
昨天讲了不是
12号不是
？2个拜五啊
22号。
这个拜五。这个拜五。The exam scope should be until here lah, until this epsilon delta. Okay. Maybe I will ask you to show epsilon delta continuity of one function. Okay, and the definition of continuity.
应该起码有10分，我感觉。
不管它几分，你只要把完整答案写出来，就有满分。Okay, yeah, this is very easy.
然后好像找到2个 relation， 但是有点做其他的事。找啊。好的，
是。But then 如果你的答案是有逻辑性啊，你知道要怎样找，但是我找不出 ，then 你会有 most of the marks already. OK， 这个是 pure max 来的。你有 logic， 你像我讲的，我因为想要帮这个，我先把它拆开，然后我就是要确保这个东西要小于 epsilon 这样，但是我还是找不出根据，但是你会拿到大部分的分。OK。
你为什么给我们什么那个 sample 考编呢？是吗？
没有，我讲没有。你问我，然后我讲没有，然后讲你去看那种 textbook 的题目，然后 lecture 的题目。
那个 textbook 的题目，我感觉他都没有到什么讨论，还是用到不用到 definition 罢了，是？
对，没有错 ，exactly。
你的题目是不要用到多，不要用到，就是
不用。对，用 definition proving 是什么？
他那个 sub 的那个 inf 全部用到 definition 罢了。
对啊对啊，我的 proving 不是用 definition 吗？
不是，不一样一点，是有点不一样的感觉，我不知道。
你想想看那个感觉怎么？我讲是一样啊。
是没有。
OK，还有一个就是你们同学做的那个 revision notes 哦 OK，里面会有一些题目嘛。等我 approve 了那些题目，那些题目就是类似我会考的那种东西。对对对，来的是那个，反正目前只有一个人做出来了，还有很多人没有做出来。I mean 有些是在 correction 的，他们还没有发给我就是那种题目。OK，不要担心 ，make sure 你的 concept 做好来。很多题目给你做啊，我有放那个OK，现在你们很紧张题目了，是不是？这样我就可以做 promotion 了。就不然的话，每次叫你们去看，不要看了，是不是？现在紧张了，就很想看了，是不是？来，我介绍你们这本很好看，这一本超级多题目。OK，这种很多 solution 啊，obviously
那个逻辑很难的，不要
，Rudy 确实是
不要被骗。
不要被骗，怎么可以讲被骗呢？这个 scam，这个 scam 啊，按进去，no，超级多题目给你做，很多题目 ，epsilon delta 也有 proof 的题目也有，普通题目也有，
比 subject 比较好一点，
为什么呢？
因为它中等，为你都做不完的一个，你不可能做完。
谁叫你做完它？
没有这样，所以你知道 subject 他已经选给你了，知道吗？他已经选给你了，你不用做完。哎呀，那个 solution 不是全部 solution 都有，是 select solution。
那不是更惨？你有些答案都不会。
你不用，你有一 similar 才 similar 才没有实现。
人家就出那种没有手续的。
是咯？
你不要
我没有啦，我没有要害你啦，反正就是来，我就给你多一点 reference 啊，
感觉
对吗？这边这个很systematic 这本书，它从简单的题目到难的题目，
以前我感觉可能有
maybe 有吧，我不叫你做完全部啊，因为有些像你讲的 similar 的人就不做哦，但是他连 similar 答案都给你哦 ，fixed matrix 没有。其实呢 fixed matrix 的答案好像是从 Darren 来的，我不知道 Darren 哪里来的，有啊有没？
有你放在那边 solution，他第一面不是吧？后面他就全部
是我给的还是？
就在你那个
OK，
你去看
OK，
每一集的
OK， 好，可以没问题。反正来这一本也有来
啊，
我们的题目了。这本书很好，其实这个 Scam 的这个出版社，你可以去找 Linear Algebra 什么它都有啊。这有一点像那种你中学参考书的嘛，很多题目的那种书。这个 version 就是这样。这个出版社 Scams Outline。OK， 你可以去找 Linear Algebra， 找其他的 Abstract Algebra 好像也有 Group Theory 有。
对，Abstract Algebra
也有。OK， 呀，这本挺好的，这本。OK， 没问题吗？没问题吗？
这个礼拜
没有 quiz， 考试啊，看你们大考的，没有小考的，大考的就没有 assessment， 我们就有 quiz。Yes。什么？
去上课啊？好好会的时间啊，
上课。啊，觉得正常进行，因为我们 lecture 也正常进行。呀，只是我们 extra 时间出来考 test 吧。
因为考到Theorem嘛，Theorem不是 quiz 那个
看一下有没有这个 epsilon delta content 哦，如果有的话就有啊。OK， 先读一读，做你的cheat sheet 出来 ，and then 我们再看怎样啊。cheat sheet，yeah。
继续把那种
Yes. Yeah. 你可以试一下你的cheat sheet，然后重新做 quiz， 看一下做得出吗？重新拿来做你的 quiz， 看一下做得出吗？确保你的cheat sheet 有用啊，不要抄了一大堆进去，等下不懂要找什么答案。OK， 确保它有用，才带进来。
因为很多学生是来，他觉得来哦，大概进去有没有用到哦？因为他不知道自己在抄什么，所以你 make sure 你抄了那个 cheat sheet，回去读你的 assignment，读你的 tutorial，读你的 quiz，看看是不是能够用到里面的东西。OK，make sure 它有用，懂怎样用你的 cheat sheet。OK，可以开始写了，曲线。OK，
一点到2点开始。
1点到2点开始，所以
他讲我
OK，呀，可以开始写了，写有用的东西进来，有些记得的东西就不用了，不记得的东西写下，重点的东西写下。OK，还有问题吗？没有。OK，then we'll see you tomorrow tutorial。